Hey, what's up everyone, Hicham HAMZAOUI here for a new video tutorial about how to create your own 2D video game using Unity 3D. In this video we're gonna make our first steps with the Unity environment and have an overview about the different features proposed by Unity. Then we're gonna make a little character here move, jump and double jump by doing some C# coding and scripting. And finally, we're gonna work on the camera movement plus the creation of prefabs for a more dynamic video game. Now execute your Unity 3D and let's do it! When you first open Unity 3D, you're gonna end up with this screen. Click on New, give a name to our project. I'm gonna name it Robots vs Zombies. Set the project location. Hit 2D because it's a 2D video game and click on Create Project. Here we go, this is the Unity 3D environment. It is composed of multiple views. The first one is Hierarchy. It contains all the game objects present on the scene. The scene is where we're going to do the majority of our work. The Inspector contains all the settings and parameters of a selected game object inside the hierarchy view or on the scene. The project preview is basically our workspace. It shows up all the folders, images, resources, audio that we're going to use for our work. The game preview represents the final result of the execution of our game. The console shows up all the information and errors that can occur during the execution or scripting. Alright, let's get to work. First we're going to create multiple folders for a good organization of our work. To do that, hit right, create, folder. The first one is called scripts. It will contain all our scripting and codes. The second one is sprites, containing all the images of our game. Audio, obviously is for the audio. Resources, animations, and finally scenes, where we're going to save all our level scene. Of course, I'm going to speak about those two folders called animations and resources in later videos. For our tutorial purpose, I just prepared a folder called sprites that contains all the images and sprites that we're going to be using for the creation of our game. You can download it in the link below. You just have to copy all the folders and pass them inside our game project and exactly inside the sprites folder that we just created. For the record, I just downloaded those images from a cool website called GameArt2D, which proposes free sprites. I downloaded the robots and zombies and of course the platform. Alright, go back to Unity. We see that our images are freshened. Go inside sprites and you're gonna find all the folders and images that we just copied. Cool! Go inside robot folder, drag and drop the first image of the robot, it's called idle 1. Go inside others, take the platform, put it on the scene. To have a good view of the scene, double click on main camera. See the final result go inside the game preview. I'm just going to rescale our robot by clicking on this button here. You can use the inspector parameters of scale. I'm just going to use the mouse. Doing this for the robot and doing the same for our platform to have a good rendering. And I'm just going to hit play to see the final result. And obviously nothing happens. It is normal because Unity considers those two objects as simple images. Let's make things more dynamic. First, I'm just going to rename the first object as robot, the second one as platform for a clean work. Now select the robot. We're gonna make it behave as a solid object. To do so, click on component. You see Unity proposes a lot of components. hit Physics 2D and select Rigid Body. Rigid Body contains a lot of parameters going from the mass to the gravity scale, etc. Let's hit play to see the final result. What we see is that our robot behaves now as a solid object and which is under the influence of the gravity. But what we want to do is to make our robot land on the platform. To do that, I'm going to use a very important component on Unity. It is called Collider. It is inside Physics 2D and it has a lot of shapes. I'm just going to use the box shape. Let's zoom onto the robot by double clicking on it. You see there is a green thing surrounding our robot. It is the box collider. We're just going to reshape it to fit the robot. Basically, a collider behaves like a sensitive detector, which detects everything that touches our objects, like enemies, bullets, and even platforms. Let's hit play to see the final result. Alright, nothing happens too because we still have our platform considered as simple image. We're going to do the same, add a collider to it, and hit play. Tada! Our robot lands on the platform and stops on it. It is cool. I'm just going to change one parameter because we don't want some physics effects like this one. I'm just going to hit constraint inside the rigid body and click on freeze rotation Z. As a result, our robot is just standing on the platform without rotating on itself. Alright, let's do some serious stuff now. By serious stuff I mean doing some programming. Go to the script folder, click on Write, Create. You can choose either C# or JavaScript programming language. I prefer C# scripting. Name your file Robot Movements. This script will make the robot move right and left. Before going to coding, I'm just going to choose the default IDE I want to use. Go to Edit, Preferences, External Tools. I usually use the MonoDevelop environment instead of Visual Studio. You can choose Visual Studio if you want. Alright, double click on the script. This is basically the default C# file scripting. It contains two imported libraries, it extends from mono behaviors, and contains two important functions. The first one is start. It is called only one time at the start of the game and is usually used for initialization of the attributes. The second one is update, called once per frame. It is a sort of a loop function where we can give orders to our robot to do whatever we want. Let's go back to the scene and see what we want to do. Basically, we want to make our robot move right and left. To do that, we're going to make the X position inside the transform parameter of the game object change by pressing left and right arrow of the keyboard. Let's go back to the code. Create a float variable called speed. It concerns the speed of movement of our robot. Let's make it 0.2 float. Go to the update and write if input dot get k code dot right arrow. This is a if statement that detects if we pressed a key in our keyboard and the key chosen is the right arrow. Alright, let's go inside and make our robot move. To do that, we're going inside the transform position and we're going to try to make it change. To do that, write this dot transform dot position dot x plus equals speed. That's going normally to make our robot move. But in C# programmation, it is forbidden to do that directly. So we have to go through the vector attribute. Create a vector tree, temp robot position. We're going to use this temp robot position to save our robot position parameters, and we're going to modify the X position of this temporary position because it's a vector. It contains an X, Y, and Z attributes. So write temp position dot x plus equals this speed. Then copy this if statement, write else. Inside the else statement we're gonna pass what we just copied and change the right arrow to left arrow, and of course from plus to minus. Then you're gonna copy this dot transform dot position and make it equal to the temp robot position. What we're going to do next is that we have to make our script effective on the robot. So we're going to select the robot and take our script and put it inside the inspector of our robot, or the parameter of our robot, and then click on play. Now press the right and left arrow. Here we go, our robot moves. Alright, but you can notice one thing, that our robot is not flipping into the left side when we go to the left. That's because we didn't use the flip option inside the sprite rendering. Let's go back to the code and do some coding to make it happen. Create a void function called flip. Inside there's a attribute called isLeft, a boolean one. Then we're gonna write an if statement, if isLeft, and by the way write the else statement, so we're just going to copy and paste the code inside our statements. Then write this dot get component, because we're going to access the sprite rendered component of the game object. Choose sprite rendered, then change the flip x parameter to true. Copy and paste the same code. We're just going to change the true to the false. Some of you would just think that the best way to do it is just to make the isLeft attribute instead of true or false. I agree with that, but I'm just making this code because I'll be using it for the animation in the later video. So let's take the flip function, go inside the right statement, copy it, paste it, and then make it false. Then do the same for the left side and make it true. Save, go back to the scene and hit play. Alright, let's see, here we go. This is a good result. Our robot is no longer doing the moonwalk. Now we're gonna try to make our robot jump and double jump. To do so, we're just going to create another collider that is going to detect either our robot is on the ground or is jumping. To do so, I'm just going to create empty game object like this one. It is not visible in the scene. I'm just going to rename it ground detector and select an icon so it would be visible inside the scene. Let's choose the blue one. Alright, now change the position of this ground detector to the foot of our robot, because this, and add a box collider to it. I'm just going to change the shape of my game detector, double click on the robot and change the shape of our ground detector to be tiny and just as we need it. Scale it down. Alright, and after that I'm just going to parent it to the robot so that it will no longer be independent and will depend to the movement of the robot. Alright, let's create our script. Create C#. Name it robot jumping. Then double click on the script. Inside this script, create a bool attribute called isRobotJumping. Make it false by default. Then we're gonna use the rigid body 2D of the game object to make our robot jump. Create a rigid body to the RB, and then we're going to do the initialization of our RB inside the start function. So call this.transform, and because our robot is the parent of our ground detector and is the one who have the rigid body, we're just going to call it through the parent. So this transform.parent.get component, and then we're going to call the rigid body to the like this one. Let's go to the update method, write if. We're going to detect our up arrow, do the same as the movement, input.get k, but we're going to add down because we only wanted to do it only one time when we press the up arrow, not while we're pressing like we did in the movement. Alright, kcode.up arrow. Go inside our statement and create another if statement about the is robot jumping. So if our robot is not jumping, so if not is robot jumping, then we can make it jump normal. To do that, write rb.velocity. We're going to use the velocity to make our robot jump, equals new vector 3 0. So the movements will only concern the y position 15 and 0. Let's make it more dynamic by adding an attribute, a float attribute, public float called jump velocity, and put it inside the start, given by default for 15. Jump velocity equals 15, and then put it inside the y position of the vector 3. And finally, we are going to say that our robot is jumping. So is robot jumping equals true. Go back to the scene, click on the ground detector object, and then select our script and put it inside the attribute. Hit play and press up arrow, and you see that he's jumping, but unfortunately he's jumping only one time. That's because we didn't detect the on the ground position, because if our robot is on the ground, we should say that is robot jumping equals false. He is no longer jumping. To do that, we're going to use some methods or functions of the collider proposed by the collider. So void on collision to the, or collision enter to the, collision to the call. This function is used by the collider to detect the collision. So once there's a collision with the collider, it is called. Inside that, make the is robot jumping false. And now we can jump unlimited times only if the robot hit the ground. That's cool. You can change some rigid body to the parameters like the mass or the gravity scale, low or make it great. Alright, use auto mass or change the jump velocity to 4. But we have done it wrong because we put the jump velocity inside the start, so it will never change once we start. So let's delete it from the start and make it 15 by default, so that we can change it and it will take effect immediately. So like this. For now, let's go back and make it 10. Alright, let's change it to 30. Okay, seems cool. Now let's try to do the double jump effect. We're going to do the same as robot jumping. Create a bool is robot double jumping, make it false, Then we're going inside the if statement and add another condition for the double jump, or not is robot double jumping, and inside we're going to make sure that if we are already jumping, we should double jump and stop one time. So if is robot jumping, so that our double jumping is true, so we're doing the double jump. And inside the on collision enter 2D, so once we are on the ground, everything is back to false. Let's try it now. First jump. Well, I forgot to change the jump velocity, make it 13 and go back. Let's see, first jump, second jump, first jump, second jump. Alright, let's make our game inside a real gaming case. Go to the platform, double click on it, press Ctrl D and move the platform to the right. Hit play. Let's make our robot jump to the other side. That's cool, but not cool enough because our game doesn't make sense if the camera doesn't follow the robot. Now we're going to make that happen by some scripting. Press stop, go back to the script folder, click on create, C# scripting, and name the file camera movement. Double click on the robot to understand the mechanism of the movement. What we want to have is an offset between the camera position and the robot position. We don't want to have the camera in the top of the robot. To do that, go to the script. First create a public game object called robot. It will help us get the robot position including other parameters. Then create a private vector3. We're gonna call it offset. Go to start for the initialization. Take the offset, make it equals to transform dot position minus robot dot transform dot position. Save it. That will basically saves the distance between our camera position and the robot position. Let's use it now for the movement. Go to the update, hit transform dot position equals, take the robot position, robot dot transform dot position plus our offset. Save it, go back to the scene, click on the camera and take our script to the parameters of our camera. And don't forget to initialize our robot attribute by dragging and dropping the robot game object inside the script. So click on main camera and drag and drop our game object directly. It will take the exact parameters of our robot and can use it. So hit play and make our robot move. You see that our camera now follows the robot. You can change the distance between the two to have a good vision of the game, and the position will remain the same. Cool. To have a clean work, better store your game object inside prefab. Fortunately, Unity has a prefab asset types that allows you to store a game object complete with components and properties. To do that, go inside the resources folder, create prefab, and name it robot. We're gonna save our first object called robot. You just have to drag and drop it inside our box. Now drag and drop our new prefab inside the scene. A prefab acts as a template from which you can create new object instance in the scene. Any edit made to a prefab assets are immediately reflected in all instances produced from it. Now let's do the same thing for the other objects. Prefab, platform, and take our platform and put it here. And finally the camera. Prefab, camera, and take the camera inside the box. Then we're going to remove our copied platform and replace it with our prefab platform. You can create your own environment using the prefabs like this one to finally have a satisfying result. Hit play. There you go, you've got your first 2D character moving, jumping, and followed by a camera. And finally, to not forget, you should save your scene. To do that, go to File, select Save or Save As you want. Then go to Scene folder, name it Level 1, and save it. Cool, now you've got your work saved and your level saved. Okay guys, that's it for this episode. In the next episode we are going to make our robot shoot and add the animations. You can download the source codes from the GitHub. If you have any question you can ask me in the comment. If you enjoyed this video, don't forget to leave a like, subscribe to our YouTube channel or follow us on Facebook and Twitter. See you next time!